Dear students, in this class we will see some important compounds of calcium. First one, calcium oxide or quicklime. Its chemical formula is CaO. So CaO is calcium oxide or quicklime. Method of preparation. Calcium oxide is prepared by heating limestone. Limestone is chemically calcium carbonate. So if you heat calcium carbonate, you get calcium oxide and carbon dioxide. Or thermal decomposition of calcium carbonate will give calcium oxide and carbon dioxide. So in this way you can prepare calcium oxide or quicklime. Now physical properties of calcium oxide. It is a white amorphous solid. It is not crystalline in nature. It is amorphous and it has got a very high melting point. The melting point of calcium oxide is as high as 2870 Kelvin. So very high melting point. Now look at the chemical properties of calcium oxide. Calcium oxide absorbs moisture and carbon dioxide. So it can absorb moisture, water and carbon dioxide. If it absorbs moisture, calcium hydroxide is formed. CaO plus H2O gives CaOH twice. And if calcium oxide absorbs carbon dioxide, then calcium carbonate is formed. CaO plus CO2 gives CaCO3. Calcium oxide is basic in nature. It is a basic oxide so that it can react with acidic compounds. For example, CaO, calcium oxide, which is basic, react with silicon dioxide, which is an acidic oxide. Silicon dioxide is acidic in nature. So both reacts to form calcium silicate, CaSiO3. Similarly, calcium oxide react with the oxide of phosphorus, which is also acidic in nature. You get calcium phosphate. So CaO plus P4O10 will give Ca3PO4 twice, calcium phosphate. So being basic in nature, calcium oxide reacts with the acidic compounds. Uses of calcium oxide, it is used in the manufacturing of cement. Calcium oxide is the major component of cement. It is used in the manufacture of sodium carbonate. It is used in the purification of sugar. Now second compound, calcium hydroxide or slaked lime. Its formula is CaOH twice. So calcium hydroxide is otherwise known as slaked lime. Preparation. It is prepared by adding water to quicklime. So if you add water to quicklime, CO is the quicklime, you get calcium hydroxide. And this process is known as slaking of lime. So addition of water to quicklime to form slaked lime is known as slaking of lime. That process is known as slaking of lime. And the product is known as slaked lime or calcium hydroxide. Now physical properties. It is a white amorphous solid. It is sparingly soluble in water, not very soluble in water, only partially soluble in water. Now what is lime water? The aqueous solution of calcium hydroxide is called lime water. So if you dissolve lime, if you dissolve calcium hydroxide in water, you get an aqueous solution, and that solution is known as lime water. Milk of lime. A suspension of calcium hydroxide in water is called milk of lime. Suspension means heterogeneous mixture. So a suspension is heterogeneous in nature. So a suspension of calcium hydroxide in water is called milk of lime. So lime water is a clear solution. It is homogeneous in nature, but milk of lime is cloudy in nature and it is heterogeneous. So note the difference. Lime water means the aqueous solution of calcium hydroxide and milk of lime is a suspension of calcium hydroxide in water. Now look at the chemical properties. When carbon dioxide is passed through lime water, it turns milky due to the formation of calcium carbonate. So if you pass carbon dioxide gas through calcium hydroxide, that is lime water, which is colorless, it is a clear solution. Lime water is a clear solution. Then if you pass carbon dioxide through that clear solution of lime water, it will be converted into calcium carbonate. That is, calcium carbonate is insoluble. It is a insoluble white precipitate. So this solution becomes milky. The solution turns milky due to the formation of white calcium carbonate, white insoluble calcium carbonate precipitate. So this test is used for the detection of carbon dioxide gas. Okay, so carbon dioxide gas can turn lime water into milky. And if you pass excess carbon dioxide, so if you continue the passing of carbon dioxide gas through the solution again becomes colorless because calcium carbonate will dissolve on passing of carbon dioxide to form calcium hydrogen carbonate, calcium bicarbonate or calcium hydrogen carbonate. So this solution is white in color. If you pass carbon dioxide, if you continue the passing carbon dioxide gas, then calcium carbonate becomes colorless calcium hydrogen carbonate. That means the milky appearance of the solution will be converted into a colorless solution. Okay. Now reaction with the Cl2, reaction with the chlorine. So milk of lime, calcium hydroxide in the form of milk of lime will react with the chlorine to form CaOCl twice plus CaCl2 plus H2O. So this is a very important compound. It is called bleaching powder. So this is how bleaching powder is prepared. So bleaching powder is prepared by passing chlorine through milk of lime. So note the chemical formula of bleaching powder. Now uses of calcium hydroxide. It is used in the preparation of mortar. So mortar is a mixture of calcium hydroxide and sand. It is used as a building material. Calcium hydroxide is used in whitewash due to its disinfectant nature. So calcium hydroxide is used in whitewash due to its disinfectant nature. So it can keep away insects. Okay. Next use, it is used in glass making, in tanning industry, in the preparation of bleaching powder, etc. So these are some uses of calcium hydroxide. Now calcium carbonate, CaCO3. So calcium carbonate is found in nature in the form of limestone, chalk, marble, etc. So these are different forms of calcium carbonate in nature, and it is prepared by reaction between calcium hydroxide and carbon dioxide. So if you pass carbon dioxide gas through slaked lime, that is calcium hydroxide, you get calcium carbonate. So this is the preparation of calcium carbonate. Another method is reaction between calcium chloride and sodium carbonate. Reaction between calcium chloride and so sodium carbonate, you get calcium carbonate and NaCl, CaCO3 and NaCl. Now physical properties. It is a white fluffy powder, very soft powder. It is almost insoluble in water. So note that calcium carbonate is insoluble in water. Chemical properties: on heating calcium carbonate, calcium oxide and carbon dioxide are formed. So this is the method of preparation of calcium oxide as we have studied a short while ago. So we have to heat it at a very high temperature of 1200 Kelvin. So on heating calcium carbonate, calcium oxide and carbon dioxide are formed, and the calcium carbonate can produce carbon dioxide gas on reacting with the dilute acids. For example, HCl can react with calcium carbonate to form calcium chloride, H2 and carbon dioxide. In the same way, calcium carbonate react with the sulfuric acid to form calcium sulfate, water and carbon dioxide. So carbon dioxide gas is produced as a result of reaction between calcium carbonate and dilute acids. Now uses: it is used as a building material in the form of marble. It is used in the manufacture of high quality paper. It is used as an antacid. Antacid means the substances that reduces the acidity of stomach. That is antacid. And it is used as a abrasive in toothpaste. So toothpaste contains calcium carbonate. Its role is it acts as an abrasive, and it is used in chewing gum. It is used in chewing gum, and it is used as fillers in cosmetics like talcum powder, etc. Now plaster of Paris. Next compound of calcium is plaster of Paris. So chemically, plaster of Paris is calcium sulfate hemihydrate. Its formula is CaSO4 half H2O. That is hemihydrate. Hemi means half. So half H2O. So this water is known as water of crystallization. So only half H2O is there, therefore it is known as hemihydrate. So calcium sulfate hemihydrate is the chemical name of plaster of Paris, or you can write it in this way also: 2CSO4 H2O. So if you multiply this with 2, you get 2CaSO4 H2O. So that also represents plaster of Paris. So chemical formula of plaster of Paris is CaSO4 half H2O or 2CaSO4 H2O. So you can write it either way. Now preparation. How is it prepared? It is prepared by heating gypsum to 393 Kelvin. So gypsum is chemically CaSO4 2H2O. CaSO4 2H2O is known as gypsum. If you heat gypsum up to a temperature of 393 Kelvin, you get plaster of Paris. So this is the equation. So we have to use 2 molecules of gypsum, and heat it to a temperature of 393 Kelvin, you get plaster of Paris, 2CSO4 H2O plus 3H2O. So plaster of Paris is prepared by heating gypsum up to a temperature of 393 Kelvin. So this temperature is very important because if you heat the gypsum at a temperature higher than 393, then what happens? All the water content, all the water of crystallization from the gypsum will be lost. So when gypsum is heated above 393 Kelvin, all the water of crystallization is lost to form CSO4. This is called dead burnt plaster. So very important. So if you, this is a gypsum, you are heating at a temperature of 393, above 393 Kelvin, then all the water content. So here 2H2O, 2 into 2, 4. Therefore, there are totally 4 H2O molecules. Then all the 4 H2O molecules will be lost to form CaSO4, anhydrous form. This is anhydrous form. Okay, and this is known as dead burned plaster. CaSO4 is known as dead burned plaster. So note it. So how dead burned plaster is formed? When gypsum is heated above 393 Kelvin, all the water of crystallization is lost to form CSO4, and the CSO4 is known as dead burned plaster. Now uses of plaster of Paris, it has a property of setting with the water. If you add water to plaster of Paris, it will undergo setting. Therefore, it is used in the making of statues. This property is used in the making of statues, and it is used in building materials, building industry. It is used as a building material. It is used in plasters, that is immobilizing the affected part when there is a bone fracture. Okay, so in the case of bone fracture, the affected part is immobilized using plasters. So plaster of Paris used in plasters. It is also used in dentistry, right? So these are the some uses of plaster of Paris. So these are some compounds of important compounds of calcium.